In this video, we're going to solve our first quiz, which is to prove that position vector of incenter of triangle ABC with position vector of vertices as alpha vector, beta vector, gamma vector, and length of sides as A, B, and C is equals to A times alpha vector plus B times beta vector plus C times gamma vector divided by A plus B plus C. Before we go there, let's see what is incenter. So incenter of a triangle is defined as the point where an angle bisector meets. So angle bisector of A, angle bisector of B, and angle bisector of C meets at a point I, which is called incenter. Note, all of the three angle bisector meet at one common point. This is called concurrency of incenter. So all of the three angle bisector will always meet at one common point I. So we will assume this in this particular video that this is true, and we're not going to prove it. However, we will see probably somewhere in my later videos that incenter of a triangle are concurrent. However, let's in this particular video prove this particular formula, which is a I vector or a position vector of incenter is A alpha vector plus B beta vector plus C gamma vector divided by A plus B plus C. Okay, we have a triangle ABC. AP is an angle bisector of angle A, so this angle is equal to this angle. BR is an angle bisector of angle B, so this angle is equal to this angle. And CQ is an angle bisector of angle C, so this angle is equal to this angle. We need to find what is the position vector of phi. To start with, let's first find out what is the position vector of P. So if this angle is theta, this angle is 180 minus theta. So triangle APB, if I apply a sine law, sine of A by 2 by sine of theta is equals to the ratio of the opposite side of a triangle, which is BP upon C. Similarly, triangle APC, which is sine of A by 2 from sine of 180 minus theta is equals to CP by B. This is equals to sine of A by 2. Sine of 180 minus theta is sine theta is equals to CP by B. Right? So let's assume this is equation 1 and this is equation 2. So from equation 1 and equation 2, we get BP by CP is C by B. So BP by CP is equal to C by B. So what does that mean for a position vector of P? So position vector of P is equals to BP into gamma vector, CP into beta vector by B plus C, right? So what does that mean? What is C? P, which is B into beta vector, is C into gamma vector upon P plus C. Since we know the ratio of BP into CP, the position vector of P is B into beta vector plus C into gamma vector upon B plus C. Now, in order to find a position vector of I, if I know AI by IP, I can find out what the position vector of P is. So if I know AI and IP, I know what is the position vector of A, I know what is the position vector of P, then using a section formula, I can find out what is the position vector of I. So let's prove. So if we know the position vector of P, we now need to prove AI by IP. Now find out what is AI by IP is. So let's take triangle A, P, P. What we can say of the ratio AI by IP. So this is an angle bisector. So as we have proved earlier, AI by IP would be C by length of BP. And similarly in triangle APC, AI by IP is nothing but B by CP. So let's take equation 3 and let's say equation 4. So from equation 3 and equation 4, we can say BP plus CP, so BP plus CP is C AI by C IP by AI plus B into IP plus AI. So BP plus CP is A is equals to B plus C into IP by AI. So therefore AI by IP, which is the original one that we wanted to find, is B plus C upon A. So AI plus IP is B plus C on A. Now if I use a section formula on AP, we'll say position vector of I is IP into alpha vector plus ratio of AI, which is B plus C, into position vector of P upon A plus B plus C. But position vector of B is nothing but B beta vector plus C gamma vector upon B plus C. So if we substitute here, we would get A alpha vector plus B beta vector plus C gamma vector upon A plus B plus C. As the position vector of an incenter of a triangle is given by A alpha vector plus B beta vector plus C gamma vector divided by A plus B plus C. Great. In the subsequent videos, we would do the solution for other two quizzes.